Hello everyone, so our assigned topic is all about probability. For the topic 5 of a reporting. Probability is simply the likelihood or something happens. So the analysis of event governed by the probability called statistics. So the probability term also written in letter P. This one. So the terminologies of the probability or experiment in which a process by which an outcome is obtained. Example is a rolling dice, a flipping coin. And sample space is a set of all possible outcomes of an experiment. An example of a sample space is a sample space for a dice rule is 1, 2, 3, 4, 5. A sample point is an element of a sample space. So, example is 1 is the sample point of a sample space for a die rule 1, 2, 3, 4, 5, 6. So, event is an outcome of defined collection of outcome of a random experiment. It is a subset of a sample space. So there are two types of an event: a simple event and a compound event. Simple event is an event with one outcome. Compound event is an event consists of two or more outcomes. So examples are getting a number less than 2 or greater than 4 when spinning the spinner once. So this is a simple event. There is one event getting a number less than 2 or greater than 4 from one spin or the spinner. So another example of an event is getting heads when a coin is tossed and getting a 3 with when a six-sided number die is rolled. So this is a compound event. There are simple event getting the head on a coin and a 3 on the other sided number die. So the probability of an event, if an experiment's outcome are equally likely to occur, then the probability of an event E is a number of the outcomes of n E divided by the number of outcomes in the sample space. So formula is P E a number of way it can happen divided by the total number of outcomes. So probability of a number equals number of ways it can happen divided by the total number of outcomes. The probability of an event. So here's an example. Probability of an event equals number of ways it can happen divided by the total number of outcomes. So a flipping coin. So what's the probability of the coin landing on head? So head and tail. So P head equals 1/2 equals 0.5 or 50%. How that is it comes? So head and tail. So number of ways it can happen is 1. So total number of outcomes is 2. So 1/2 equals 0.5 or 50%. So here's another example of a probability of an event. So a rolling die. What's the probability of a rolling one? So 1, 2, 3, 4, 5, 6. So P, so 1. And then number of ways it can happen is 1. And then the total outcomes are 6. So 1 over 6. Here's another example. So what's the probability of rolling a 1 or a 6? Then here, P 1 or 6 equals 2 over 6. How does it come? So there are two ways that it can happen. So the 2, number 2 divided by 6, the total outcomes equals 6. So 2 divided by 6 equals 1/3. So what's the probability of a rolling 1 or a 6? Equals 1/3. So another example of probability of an event. Probability of drawing cards. So what's the probability that we draw on a speed? So here, speed is this one. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king. So there are 13 cards. So here, number of ways it can happen is 13 divided by 52, the outcomes of an event. So 13 divided by 52 equals 1/4. So 1/4 or 0.25 or 25%. This one, speed. So remember, the probability of an event P is often written as PA. So the probability of an event can only be between 0 and 1 and can be also written as a percentage. So if PA equals 0, event A will almost definitely not occur. So if PE is close to 0, there is only a small chance that event A will occur. So if PA is close to 1, there is a strong chance that the event A will occur. So if probability of an event equals 1, event A will almost definitely occur. So the sum of all possible probabilities of all possible event equals 1. Here are the ways to remember the probability of an event. Let's proceed. So, counting rules. So, many times a person know number of all possible outcomes for a sequence of events. So, to determine this number, 3 rules can be used. So, first, the fundamental counting rule. Second, the permutation rule. And the third, the combination rule. First, we talk all about fundamental counting rules. So, in a sequence of n event in which the first one has key 1 possibilities and the second event has key 2 and the third has key 3 and so forth. So, the total number of possibilities of the sequence will be key n, key 1 times key 2, key 3, key 4, and the rest. So, infinite. Here's an example of an counting rules. Tossing a coin and rolling a die. So, a coin is tossed toss, and a die is rolled. So find the number of outcomes per the sequence of an event. So there are 1, 2, 3, 4, 5, and 6. So then key 1 is 2. And then key 2 is 6. So hence, number of possible outcomes is key times key 1 times key 2 equals 2. 2 times 6 equals 12. As key 1 is 2, and the possible outcomes equals 12. As a 2 times 6 equals 12 here. Another example of accounting rules. Paint making. So a paint manufacturer wishes to manufacture several different paints. So the categories include color, type, texture, and use. So color: red, blue, white, green, brown, yellow. Type: latex, oil. Texture: flat, semi-gloss, high gloss. Use: outdoor and indoor. So how many different kinds of paint can be made if you can select one color, one type, one texture, and one use? So, and key 1, there are 7 color: the red, the blue, the white, the green, the black, the brown, the yellow. So here you put 7 in key 1. And then the key 2, the type, there are 2: the latex and the oil. So we put 2. Key 3, the texture, there are 3 texture: the flat, semi-glues, and high glues. And the key 4, the use. So there are 2: the outdoor and the indoor. So we put the number here. Then the number of possible different paints equals key 1, key 2, key 3, key 4. So there are 4 possible answer. So we multiply it all. So 7 as key 1, 2, K2, K3, and the rest. So 7 times 2 times 3 times 2. So 7 times 2 equals 14. 14 times 3 equals 42 times 2 equals 84. So the number of the possible different paints of a paint making is 84. Another example of the counting rule. So paint making, also a paint making. So what's the probability of getting a latex type paint? So latex. So first we have K1. The color: red, blue, white, green, black, brown, yellow. The type: latex. The texture: flat, semi-glues, high glues. The use: outdoor and indoor. So probability of an event equals number of ways it can happen divided by the total number of outcomes. So number of getting latex paint rather equals 7.7 times 1 times 3 times 2 equals 42. How does it come? So we get 7 from the color: red, blue, white, green, black, brown, yellow. And we get 1 from type: latex. And then we get 3 from the texture, flat, semi-loose, and high-loose. And we get 2 from the use, outdoor and indoor. So 7 times 1 equals 7 times 3 equals 21 times 2 equals 42. So number of ways getting a latex pen equals 42. So here's another. So probability of getting a latex paint. So 42, the number of ways it can happen. And then the total number of outcomes is 84. So 42 divided by 84 equals 1 half, equals 0.50 or 50%. The probability of getting a latex paint type is 0.50 or 50% here. So we move forward to the permutation rule. So a permutation is an arrangement of n object in the specific order. So the permutation rule is arrangement of n specific order using r object at a time is called permutation of n object taking r object at a time. So it is written as np r, and the formula is npr equals n infinite divided by n minus r infinite. So an example of this are, so here first example, business location. Suppose a business owner has a choice of 5 locations in which to establish her business. So she decides to rank each location according to certain criteria, such as price of the store and parking facilities. How many different ways can she rank the 5 locations? So n is a number of location and r is the rank of a location. So 5, n equals 5, r equals 5. So here any formula. So n permutation r equals n infinite divided by n minus r infinite. So we substitute 5 infinite divided by 5 minus 5 infinite equals 5 infinite divided by 0 infinite. So here we get 5 times 4 times 3 times 2 times 1 from the 5 infinite divided by 1. So 5 times 4 times 3 times 2 times 1 equals 120. So how many different ways can she rank the 5 location? The answer is 120. Another example of a permutation rule. Television ads. So the advertising director for a television show has 7 ads to use on the program. If she selects one of them for the opening of the show, one for the middle of the show, and one for the ending of the show, how many possible ways can this be accomplished? So n equals 7 as it has 7 adds to use on the program, and then R equals 3 as it has a 3 selection. So N equals 7, R equals 3. So we compute 7 permutation 3 equals 7 infinite divided by 7 minus 3 infinite. So here, 7 infinite equals 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. So we get 7 minus 3 equals 4. So we get 4 infinite and the rest. So we cancel this one as it has the same. 7 times 6 times 5 equals 210. So how many possible ways can this be accomplished? So 210 possible ways as the answer. So we move forward to the combination rule. So a combination is a selection of all or part of a set or object without regard to the order in which they were selected. So the number of combination of n object taken R at a time is denoted by in, C, and R. So it has the same last sa permutation. So order doesn't matter and repetition is not allowed. So n object taken are at a time. Here. So examples of a combination rule. First example. So how many different ways can you select two letters from the set of letters X, Y, and Z? So there are three letters. So 3 number and a 2 different ways. So R equals 2. So we substitute this 1. 3 infinite divided by 3 minus 2 infinite times 2 infinite equals 3 infinite, then 3 minus 2 equals 1 infinite times 2 copied to infinite. So we have here. So 3 infinite equals 3 times 2 times 1. 1 infinite is 1. 2 infinite is 2 and 1. So we got 3 times 2 times 1 divided by 1 times 2 times 1. So we have 3. So how many different ways can you select two letters from the set of letters X, Y, and Z? So we have 3. The answer is 3. Another example is, given a club with 10 members, in how many ways can a committee of 3 be selected? So we have 10 members, so the number is 10. R equals 3 as the ways must be selected 3. So here we substitute using the formula of a combination rule. We have here that 10 infinite equals 10 minus 3 infinite times 3 infinite. So we get 10 minus 3 from n minus 3. So we substitute this one. So move forward. 10 infinite divided by 7 infinite times 3 infinite. We get 10 minus 3 equals 7. We get it from here. So it is 7. It is 7 infinite equals, so the 10 infinite, we have 10 times 9 times 8 times 7. Why did we stop on 7? Because the last number is 7, so we must stop it. And then we copied also the 3, the denominator. So 10 times 9 times 8 divided by 3 infinite equals 720 divided by 6. So how does we get 6? The infinite of 3 is 2 times 3 times 2 times 1. So it is equals to 6. So we have here 6. How does we get 720? So it comes from here. 10 times 9 times 8. 720. So from getting that, we must divide. So 720 divided by 6 equals 120. So in how many ways can a committee of 3 be selected? So there are, the answer is 120. So here, the probability of an event equals number of ways it can happen divided by the total number of outcomes. The first, the second, the key times key 1 times key 2 times key 3, key 4, and infinite. And then the n permutation takes object R equals n infinite divided by n minus R infinite. From the computation, we have n computation R equals n infinite divided by n minus R infinite R infinite. So, thank you!